Hi there, and welcome back to Triplicate. And don't seem to have been getting much content out recently. Just seem to be permanently busy with other things. Amongst other things, had the cataract done at the end of last week in my left eye, so my vision is a lot better at least, which will help get on with things. But that's 2 days, and it's only minor local anaesthetic surgery, but still surgery, and it takes it out of you. Anyway, let us press on and get back on with the battery charger, which I want to get finished up and working, because I'm still using my good old modified eBay clock to measure battery capacity of rechargeable batteries. So last time we got it working so we could set a program of discharge, charge cycles and measure the current and how long it was taking to do these, so we could get the capacity and so forth out of it. And all we wanted to do now was get the display working on the PC end and get it to be able to throw out the capacity value and anything else we want. Unfortunately, once I started that, I discovered that a lot of the code in here was cobbled together just to get the last video out, so I ended up having to do quite a lot of rewrites. I also found that my test charge discharge thing, which is just a power supply across some resistors, had a pot on it. Let's see if we can get this to the camera to see that. Has burnt out. There we go, that side. Come on, focus, focus. There we go, you can see it's burnt out and the wire's gone. So what I've done now is just got a pair of resistors, and they're connected to my 10-watt variable power supply, and I'm powering the, you see it's not running at the minute, I'm powering this lot off just a 12 volt plug-in wall thing. It seems to do the job. Okay, so I have the software working in some way, shape or form, not, I suspect, without bugs, but we will proceed as we are and fix bugs as we go along. So here we go. There we go. So I have got the graph bit working, and I have done a simulate, and you can see the run voltage is yellow, the monitor voltage is green, the current is red, and we have these little things which allow us to scale the graph, and I haven't put axes or anything on the graph. It's all a hack, it has to be said. And we can save and load these analysis files. So if I load an analysis, eventually the battery charger test, and they're a CSV format, and it doesn't save the settings on the graph scaling, so you finally have to fiddle with them as we go along. As I say, it's a hack, it's not a piece of commercial software. So shall we try and record some data off our test jig, and if that's successful we could put a battery on it and see what that does. Okay, so attempt number 2. We have our little test battery sequence here, which discharges the battery down to 3 volts at 200 milliamps, charges it up to 6 volts at 100 milliamps, and then just monitors it. This is not intended to represent any real battery, it's just for test purposes. And the first time I had this timeout set to 1 and the timeout scale, I'm running it fast, so instead of like a 5-minute update, it's running on a, I can't remember, 20-second update or something, just again for testing. So I had it timed out on the charge, which confused me, and the screen recorder switched itself off for some reason. Anyway, off we go. So action, run. Have I sent the... No, I haven't. Oh dear. Action, send. So we upload the battery to the Arduino and hit run, and there we go, the yellow light is on, it's running, and you can see it's mostly at 4.8 and then 5.9, just under 6 when it's monitoring. And why is that? Suddenly drawing more current, I don't know. Because this is 13 volts. Okay. So now we are going to, and there's a problem, is the left hand edge here, the first few readings that are getting drawn off the graph, off the left hand edge of the graph. Oh, it started. Should we bring that down to there maybe so we can see it? So I am now going to gradually reduce the voltage so it's discharging. Not so gradually, I think. Until we get down to around 3 volts, where it will switch on to charging back up again. And I'm not going to trouble you with what's probably going to be a few minutes of me turning the voltage down gradually, just to get a graph, a decent graph here. So I will bring you back. Okay, you see there, I'll show you it again. We're at 3.1 something volts, so we are not far off this going into charge mode. 3.0 something something. So what's that? 2.9, yep, and it flips into charge mode, and now the charging voltage is 3.5 and the monitor voltage is again 2.9. So we start ramping it up again. So in a minute The display should catch up and show the run voltage. Yeah, there we go. The run voltage has now gone above the monitor voltage, so we shall start ramping it back up again until we get up towards 6 volts, and then I'll show you it flipping from charging just to monitoring. Okay, so now if we look here, wait for the monitor voltage. For monitor voltage 5.6, so we are getting there. So let's carefully ramp this up. 5.7. 5.8. 5.9 nearly. Oh, yep, and there we are, we've flipped in, and that is monitor mode. So we're getting 5.98, 6 volts to you and I. And if we look on the display when it catches up, you can see here it's continuously sending the data it's recording, and it duplicates the display every time it sends a new one. There we go. So yeah, the run and the monitor are now the same because the current's gone down to 0, and if we let that run a bit we will get a grey bar here indicating monitor, and as I say, the run and the monitor voltages will now sit at the same value, and we can leave that however long we like in monitor mode. We'll leave it a minute or two, and by the miracle of video it won't be a minute or two for you. Right, we are going to save that as test. As what are we going to call PSU test test.csv, like that. And now we're going to try it with the battery. So I need to think, do I need to make any changes to anything to do that? Yes, I need to go and get it going at the normal speed, don't I? Okay, time to try it with a real battery. And here we have a real battery, which is a Loitron. But batteries off those and they seem to be okay, and it's an 1100 I believe AAA. I'm using a 1100 AAA because it'll discharge and charge up quicker. So shall we plonk that in the holder, and it doesn't go in terribly brilliantly on account of it being a holder for an AA, and we're gonna persuade the meter to turn on, and it's 1.22. No, what am I saying? 1.422. So that's charged. So we are going to discharge it and recharge it up, hopefully. Just a quick note, I've repurposed that to come on while it's turn the current drain or charge off and monitor, rather than having it be an error stroke stop LED. So let us run the Oh, I did a tweak, so it's going to recompile. So let us run the PC software eventually. Okay, we're here now. I've already generated a battery file for this battery, this type of battery anyway. AAA nickel metal hydride test it's called. So this capacity, so we're waiting for it to go down to 0.9 volt, and that's the monitor voltage. And then, discharge at 200 milliamps discharge, then charge 10 hours max, ending at 1.5 volts and charging at 100 milliamps. And then it will just go into monitor mode. So we are going to send that like that, and we are gonna, I don't think we need to reset, I need to sort this out. This is resetting and reloading and so forth. So now we are gonna hit run, and yes, it's gone into discharge mode and 1.354 or so while it's actually discharging, and it is going to do that for some considerable time, and the update time now is 5 minutes. So I am going to let that run for, I don't know, some while, and bring you back to show you how it's getting on. Okay, so we have just missed the thing switching from discharge to charge. See, the green light's on instead of the yellow, and if we look on here you can see that the run voltage has now gone above the monitor voltage. So there you go. So now we'll see it charge up. Just in case I haven't said, I have changed this so it will scale the x-axis according to the amount of data, otherwise we'd now have 38 little pixels cramped in the left hand end. So as data arrives it reduces the X scaling. Okay, some hours later and we're done. So here you can see at the end of the charging, sorry, at the end of the discharge cycle, the voltage dropped sharply as the battery ran out of juice, and it switched into the charging, and it charged here for probably 5 hours. And then in the end you can see the voltage went up and it turned off here, and right at the end here it's in monitor mode. It's just tracking the voltage, which is dropping gradually over time, I guess, as the battery starts to discharge itself. So we have a working system, so I think we are gonna quit here, and we will actually start investigating some batteries, new, old, good, bad, in the next video. And I will crack on and write a bit of software that takes this data and calculates the charge that came out of it when it was discharging, i.e. the capacity and the charge that's been put in it when it was charging up. So we can see what those numbers are, but I say that's for the next video. So for now I'm going to call it a day for this video. Hope you find this ongoing investigation into batteries interesting, and So for good now, it's goodbye from Triplicate.
Goodbye.